So internally at the company, we basically split up software roles into hard and soft tasks. Hard tasks are software engineering tasks that are very defined and very like you can very accurately measure whether the agent got it right. So an example of this is like context selection. You have a problem, you know where the agent's supposed to go to solve it. The only thing the agent has to tell you is where in the code base to go solve it. So now basically like they'll tell you, okay, you should go here in the code base, and you can just tell, are they roughly in the right part of the code base? Have they found the right files? Have they found the right functions within the right files? And have they found the right lines within the files of code? We would definitely develop it. I think that would be needed to kind of solve problems end to end. There needs to be infrastructure for these agents to be able to hand off problems to keep kind of solving them together, and to basically reliably, almost like a communications protocol between different agents. So we would for sure develop tooling around that. I mean, you see some examples like MCP and stuff, but we would develop our own tooling to allow like our agents in particular to very quickly hand stuff off, verify output, stuff like that. We would definitely want to help incubate it. So, for example, when people publish their agent code, what does that mean? Are we just publishing random code that can be run in random ways? No, there needs to be like a standardized way to do it. So how do you design a standardized way that is open enough that allows miners to innovate in as many ways as possible? Like we don't want to tie their hands in terms of what their agents can do in like this little sandbox environment. But at the same time, we don't want them to be able to break out of that environment. Imagine like a validator is running some minor agent code, and the agent code breaks out of the sandbox and takes their cold keys from their computer. That's not good. So it's like a lot of design considerations like that.
Welcome to the Ventura Labs podcast. Today, we're joined by Shakeel, the creator of Ridge's AI, subnet 62 on Bittensor, a platform using decentralized AI agents to transform software development. His bold mission is to make human coding obsolete. He walks us through his journey from quickly building a team to designing incentives for specialized tasks. We dive into Ridge's AI's open miner code registry, scalable AI solutions, and how smart tokenomics can fuel a community-led ecosystem designed to replace software engineers entirely. And now, back to Shakeel with the 47th Ventura Labs podcast.
Okay, Shakeel, subnet owner of 62, Ridges AI. How you doing,
Yeah,
man?
good man. How are you? Good to chat.
Yeah, absolutely. It's great to get you on. And you guys have had quite the rise in the past month or so
Yeah.
since I spoke to you about setting up this podcast. So, how's it been, man? How you feeling?
I mean, good. Yeah, it's been an intense like few weeks. Kind of like we rebuilt the whole team. Just been like it's been like 6 days a week, 7 hour, like 12-hour days. But yeah, it's been good. I'm feeling good. Like we made like a lot of progress. It feels cool to like ship. I'm surprised people noticed it this quickly, but other than that, like yeah, it feels cool.
Yeah. And Ridges, you were part of Agental.
Mhm.
Agental is now Ridges AI.
Yeah,
I don't know if you want to speak on the transition of what happened there,
yeah.
but what is Ridges AI? How did it come to be? How are
Sure.
you running it?
So I mean, like I started basically Agent Tag with two other guys, and we were just kind of like all friends. This was like pre-detail, and we were working on it for a bit. But we kind of got it off the ground very close to detail, and as detail happened, just kind of as we were getting our bearings with the older system, detail happened, and we all just kind of like lost. We're like, okay, well, our incentive mechanism doesn't work. We're very far away from generating revenue. And then so basically, like the other guys were like, just kind of like, we don't want to work on this, myself included, for a bit. So we just kind of let the project die for a little bit. We didn't work on it, but I like the idea. Like I thought it had legs, and so I was like, you know what, I want to work on this. Let me buy you guys out, and so they were fine with it. So we just did like a buyout. Obviously, like we're all still in good terms. Like one of the guys is actually still my roommate. But yeah, it was just kind of like a transition like that. And then I was like, well, I'm gonna run it like a real company now. So it was just myself. Kind of hired like a team around me, just all Waterloo interns. And yeah, just kind of built it from there.
And you guys have been probably moving the fastest out of any team in BitTensor these last couple weeks.
Maybe, yeah, yeah. It's been an intense
What
couple
has
weeks.
been, did you expect this community reaction to you guys and the takeover?
No, I mean, I think if you look at like the early messages, like on Discord, like maybe 3 weeks ago now, I kind of basically said that um, like, like I know that everyone can kind of tell that like we left the project for dead, and that's not good. And so it's like we need to build credibility, and for me, the best way to do that is just to ship. And I assume, like I even told my team, I was like, I have a goal that we're kind of like in the top like 40 by end of June. and it's now like beginning of June, and we kind of hit like rank number 25, a lot faster than expected. So I wasn't expecting this kind of reaction. No.
Okay, so you guys have been moving fast.
Yeah.
You think all you need is to ship. That's how you build credibility with the community is just ship, 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 speed,
Yeah.
iteration. What have been the hardest parts on onboarding these interns
Mhm.
and building the whole new code base that you guys now have and just released yesterday?
Yeah, I mean, like, the most difficult part is kind of just getting into this mindset of incentives. Like, everyone just like kind of has to really think about how is someone going to break my code, especially because the code is public. And like we see that, like for example, like we just rolled out the code base. Like I think it was probably been out in production probably now for about half a day, and we're seeing people trying to do exploits already, adding stuff to like the responses that their AI agents are giving. Um, but I mean, kudos to them. They picked it up really quickly. Like we rewrote the code base, the core of it, in like 3 days, and then from there it's just been like bug fixing. Just like a lot of commits and stuff like that. Seeing what breaks, working with deployment. They picked it up pretty fast. I think the hardest thing was just like yeah, thinking about it in terms of incentives, all the players, the validators, the miners, why they do what they do, and like how we can kind of structure it that like we align their incentives such that they want to build a good agent. It's very different than thinking about it like if you were just building an agent yourself.
And then high level, what is that incentive design you have between miners, validators? How are miners rewarded? Or
Yeah.
first, what do they
So.
do?
So right now it's like it's basically just like a query response model where the validator sends them a coding problem and they respond with like a response called a git diff, which is basically just like a format of some code where you can apply it to a code base easily. Like a computer can automatically apply it to the code base and like run the new changes. But we're actually moving to like a whole new incentive mechanism. So our plan was kind of like first like rewrite this code base and get it like super stable and like in a much like I think it's like probably like 1/5 of the size of the old code base, much cleaner code, so we can actually move fast within it. And now we've reached that. So now the next step is like our new incentive mechanism, where instead of the validators asking a miner for a response, the miners are actually going to like post all of their agent code publicly. I could talk a bit more about that if you want, but basically what that means is that like anyone can see the miner agent code and anyone can run it by themselves if they want. And so if the agents are coming up with really good stuff, it kind of like solves the problem of having to like worry about privacy. Like where like you don't have to just send your code, your proprietary code to like a bunch of miners you don't trust. If you want, you can actually run the code yourself and use the agents on your own. But yeah, that's kind of the incentive right now, where we're moving from basically this model of the validator asks the miner a question, the miner sends back some code, and then the validator evaluates it on a bunch of different criteria, and then like basically ranks the miners and gives most of the rewards to the top few miners. To like a new one where like the miners upload all their code to like a public registry, and then the validators can then run that code themselves and evaluate it for themselves. There's also like another big difference in that like we're splitting it up. So it before it was like kind of there's like one type of problem, which is just like the validator generates some very broad problem and the miner agent has to be able to solve any kind of problem like this. Um, Let me know if I'm kind of like rambling on too much, but like we're kind of moving to like a different model where like we want the miners to focus on a very narrow part of software engineering. The reason for this is that like I think like software the writing is on the walls. LLMs are very clearly good enough to write code, but software engineering and how you actually get there is not just about writing the code. There's like a lot of like small steps that software engineers have to do. It's about like kind of like thinking about the problem, figuring out what to do, kind of looking around. Usually you'll be wrong, so you have to like backtrack. It's very like iterative. Like you have to do like a little step. You'll edit some code, you'll see what happens. You'll edit some more code based on that. It's almost like a very feedback loop kind of thing. It's hard to build an autonomous software agent end to end that can do all the little things in a row reliably. Like it's like a common thing where like let's say you have like a 90% chance that your model gets it right. But now you're doing like 100 steps. By the end, the odds that your model actually got it right end to end is almost zero. But so what we want to do is we want to basically split each step up and get the miners to like specialize in one kind of step. So either like writing the code or for example like finding where in the code base they should edit and getting really really good at that. So kind of improve the probability from 90% to like 100% in that one step. And then we basically create like a handoff layer where like when someone gives us a problem, we can split it up into all these steps and allow the agents to just focus on their one step and hand it to the next agent to do really well. Which I think Bittensor is like in a really good position to do because of like you could set up like an incentive where like you're evaluating on a very narrow criteria and giving emissions for that.
And how do these miners know which step to solve for? Do you just give them a whole code base and then they
Mhm.
just pick one thing, or do you tell them a specific thing you want fixed or changed? How does that work?
So we'll specify like a bunch of separate incentive mechanisms within our broader incentive mechanisms, almost like a subnet, where we'll give them like they can basically choose what kind of agent they want to build, and then validators will generate problems specifically focused on that one type of agent. So for example, one of them is like context solution. So we'll basically define the agent type, and a miner can register an agent as a type of agent, and then get problems for that problem type and just solve that problem type by itself.
And when assigning those problems for specific problem types, who
Mhm.
determines that? Is it all synthetic queries right now where you guys have I
Mhm.
guess, assigned questions to these niche topics?
Yeah, basically. So what we do is that we'll get like validators to generate synthetic questions right now, just like in terms of how we split up emissions, where they basically come up with a problem that's for this niche issue. They'll use like an LLM to do it. So we'll have like a whole framework for how the validator generates the problem, and that's open source for everyone to see, and then it's sent it to the miner. And the different problems will have different things that the validator will generate and send to the miner. For example, like when they're generating code, we only want them to focus on generating code. So we'll actually give them the problem statement, the whole code base if they want it, and we'll also give them the context files that we're expecting them to kind of work within, stuff like that.
And then how will this transition to organic queries? Because that's
Mhm.
obviously a very big point for building a product.
Yeah. So I mean, like I think, like I said, like building the end-to-end software engineer is very, very hard. I think it's doable, but you kind of want to focus on these one steps first. And once we get these agents really good on these narrow things, I think we can actually just start immediately selling those narrow things as services. So, for example, one example of this is unit tests, where people it's like a very tedious job to write tests to make sure that your code is good. And so oftentimes like bigger companies, what they'll do is that they'll have all these tests for their code. Someone makes a change and the code base is obviously very big and they're not looking at all the ramifications that that change might have. So before deploying that change, they'll run all these tests and they'll make sure they pass. But no one wants to write tests. But again, that's like a very narrow kind of task, you know? And so like that's an example of like an agent that we could do, where it's like a very narrow agent that just kind of solves unit tests, and then people can basically hire that agent to solve unit tests for them in their code base, or to write unit tests for them in their code base. Um, and we can basically start selling these small, narrow software engineers that can't do everything. Like it won't do a problem end to end for you. But for a small task that a software engineer would have to spend time doing, you can basically hand it off and expect that it's done properly.
And for scaling task types, how
Mhm.
long does it take to add a new type of task? And how quickly can you add tasks?
Yeah, that's a good question. I mean, like this is the trickiest part because basically for every task that we add, we have to come up with a evaluation loop for synthetic tasks where we can basically reliably generate these problems and also reliably evaluate them. And so kind of this is the way we think about this is that the first like many tasks are going to be easy to generate and create because they'll be what's called hard tasks. So internally at the company, we basically split up software roles into hard and soft tasks. Hard tasks are software engineering tasks that are very defined and very like you can very accurately measure whether the agent got it right. So an example of this is like context selection. You have a problem, you know where the agent's supposed to go to solve it. The only thing the agent has to tell you is where in the code base to go solve it. So now, basically, like they'll tell you, okay, you should go here in the code base, and you can just tell, are they roughly in the right part of the code base? Have they found the right files? Have they found the right functions within the right files? And have they found the right lines within the files of code? And so basically, like there, you can very precisely evaluate it. And there's a lot of kind of tasks like this that we want to start with, for like what we kind of build our evaluation loops on, because we can very clearly measure whether they got it right. So I think for those, it'll be pretty easy to get started. The harder ones are softer tasks. Those are things like writing code, where like you can for example create tests to test the code that an agent has written, but it's much more difficult to objectively say whether one piece of code is better than another without an actual experienced human software engineer looking at it. As in, like you don't want to just rely on a model saying this is better than this. There has to be like some rigorous way to check. And so the thinking on this is twofold. One is that you can build a semi-good pipeline for this just to get people developing agents in that direction and play kind of like a cat and mouse game of like catching exploits that come up. The other is that when you have all these hard agents that are very good and obviously like evaluated to be very good in a reliable way, you can start taking in bigger problems and let people also have agents that solve the soft part of it. So say for example, someone comes to you with like a website or they want an edit to their website and they're willing to pay 5 grand for it, just hypothetically, right? You may hire like an orchestrator agent that their only job is to find other agents that they can pay to get the job done together. Because that agent is going to be like one person. They're not going to be able to solve, or like the whole point is that they don't solve it end to end. Instead, they kind of like piece all these agents together. And so they can obviously see what are the best agents for the harder tasks because they can just select them based on their evaluated criteria. For the softer tasks, it's up to their discretion. And again, consider that they're competing for all these like basically contracts. So they'll basically pay these other softer agents and decide like that who they want to kind of use among the agents that are registered on the platform. So you end up basically creating like a market where if I am like an orchestrator and I'm trying to find the best agent to help me solve this problem, and it's like a bit of a softer task, I'll probably spend a lot more time looking at the agent outputs and choosing an agent that I can trust for the soft quality output. And so it's almost like let the free market decide for those, if that makes sense.
And that orchestration layer, is that does that fall on you as the subnet owner, or
Mhm.
is that going to be a subnet that you put on miners as well?
I'm not 100% sure. I think we can go both ways. To be honest, I feel like just like this, like whatever we develop, miners will be better at it. So I think long term it will be better for us to design an incentive that gets orchestrated models on it. And longer term, like there's going to be many kind of different tasks and many different agents. Right now, we're letting people register agents as miners, but I think long term, what you could do is the 256 miner slots or the 196 miner slots um, are just orchestrator slots where like someone they're only orchestrator agents that then look at the agents on the registry and piece them together to solve problems.
And that agent marketplace, do you think that would be something you guys develop, or would that just happen organically from the community or something?
We would definitely develop it. I think that would be needed to kind of solve problems end to end. There needs to be infrastructure for these agents to be able to hand off problems to keep kind of solving them together, and to basically reliably, almost like a communications protocol between different agents. So we would for sure develop tooling around that. I mean, you see some examples like MCP and stuff, but we would develop our own tooling to allow like our agents in particular to very quickly hand stuff off, verify output, stuff like that. We would definitely want to help incubate it.
And for commercialization, do you think
Mhm.
that agent marketplace would be your only route, or do you envision yourself building a platform similar to Cursor or Windsurf, one of those type of coding tools?
Yeah, good question. I think that there's like a few different routes that you can do. So Cursor and Windsurf, like obviously the demand for this kind of product is like through the roof, just for coding agents. But they're very synchronous. Like you're kind of like pair programming with the IDE. They're great tools. But fundamentally you're not basically giving it to a software engineer. You have like a really good kind of context finder, explainer, someone that can write little bits of code for you, but you're still in the trenches writing code. We want to operate more similar to like Devon. There's a couple different ways you can do this. One is like a GitHub extension. So where people store their code, we have an extension, and they can basically just add the extension. Like in your code base, you can go like at Ridges, fix this for me, and then we basically send it off to the miners, figure out the orchestration of all of it, and give you back a response. The other one is that like people can self-host pipelines where like they basically create like almost like Slack buddies, where on Slack you can message Ridges and you say like, hey, I have this problem, solve it, and then it goes and solves it for you end to end, and you just kind of like approve it at the end. There's a lot of different ways. I mean, once you have like a reliable way to pass things off to an agent and have it solve it for you end to end like a software engineer, there's like a million different ways you can kind of like both monetize it and kind of create an interface that makes it easy to use that. Effectively, like it's like a product manager. How would a product manager want to tell an engineer to do something?
And with being able to hand it off to this virtual software engineer, so to
Mm.
speak, is there a way to do this with private repos and protect the a private repo, or
Mhm.
can you only do it on public repos?
Yeah, absolutely. So this is the issue with our previous incentive, where it's like validators send questions to miners, because the miner holds the agent code. And so like if you even if the agents are really good, to basically get your problem solved, you have to trust it enough to send it to a miner. We're kind of moving to a situation now where like miners upload all their code in public for everyone to see. And so what that means is that like if you are a company, you have a proprietary code base, first of all, you can inspect the code yourself. Second of all, we've built a lot of tooling like internally already that we're going to release in the next couple of weeks of like sandboxing this code. So the miners can't just submit code willy-nilly. The code has to adhere to like a format that it only runs within like its own little sandbox and can't interact with the rest of your computer. Third is that you can host it and run it yourself. If you're like, let's say you're like a fund or you're like another miner that has like very secret proprietary like logic in their code, you can just copy that agent code yourself and run it on your own.
Okay, that's interesting.
Mhm.
So you're saying the miners are gonna essentially open source
Mhm.
the agent they created so other
Yes.
people can run it on their
Yes.
device.
Exactly.
How is this something you're currently doing? How far off is this from being realized?
I think we're like a week and a half, maybe 2 weeks away from rolling it out. At this pace, for sure. I mean, this is part of why the rollout of the current code base took extra time because we had two engineers on basically like getting the rollout steady, kind of making the existing code base steady, and two engineers working on another repo where they're basically rewriting the rewrite to account for this whole thing. And there's like a bunch of like security things involved with that. Um,
Okay. And when,
but yeah,
and
we're
when you say
close.
and when you say the current code base took extra time, the extra time you're referring to was 1 day, right? Or
Well, no,
less.
yes, because we were supposed to launch it on Wednesday, and it took until today to get it smooth, so 2 days. It should have
Oh.
been rolled out and smooth on Wednesday.
Okay.
Yeah.
So that's just
I
sticks to the
underestimated how long
speed.
it would take. Yeah.
Yeah, okay. Um, that's interesting. How far out can you plan then if you're moving so fast?
Not very. I mean, this is kind of like my whole approach. I think like everything in this ecosystem is moving crazy fast. Everyone has access to the same tools and ideas. We're not building proprietary models, and so our advantage is just speed of execution and quality of execution. And so it's like, even if we get the incentive a little bit wrong on day one, if by day two we fixed it, it's no problem. Um, Yeah, so I can't really plan out crazy far, but I think that's actually like a strength because like the market itself changes. And if I'm planning for like a year from now to have this built according to the current models that we have and the current agent infrastructure that we have, I mean the AI world changes so fast that like by the time that I get there, what I should be doing is probably going to be very different. And so I prefer to like operate on like maybe like a month time frames and just adjust as needed.
And it's a very valid point. The AI landscape changes very quickly.
Hmm.
Some people may say this subnet would be completely irrelevant once we're at a 10 billion or 10 trillion parameter model that can do all these things without
Hmm.
breaking it up. What
Yeah.
would be the counter argument or
I don't think that's true.
counterpoint?
I think the models are very clearly not good enough to do it. The issue that they have, like to write code end to end, they can solve all these problems, they can find the context, they can write the code. The problem is not that the models cannot think about it well enough. The problem is that it requires tooling to let the models kind of like communicate and figure all the steps out properly in a way that is inherent to models. If you get a model that doesn't hallucinate at all, then potentially you could do it, where you just pass it in and you get an output that's fully perfect. But I don't think this is true. And I think you can see that like just because of like the 90% effect, where like if you're 90% right on this and then 90% right on the next one, eventually you kind of go down to zero. You look at models like OpenAI, like they're doing all this thing of like where they're showing you the thinking. And it's like almost like steps that the model's going through between their thoughts to get better. Um, Although, yeah, it is possible that we get to like a 10 trillion model parameter model or like some crazy model that can basically do this iterative stuff and build its own tooling on the fly internally, at which point all of humanity is obsolete. So it's like, but I don't think we're gonna get there. Like I know a lot of friends that have like built companies that are at massive ARR right now. And they're not really that public about it, but they do it by basically doing this, where they build like obviously the LLM can do it, and you have to build really good tooling around it to make sure that in mission critical situations it's not hallucinating. You can rely on the outputs, and you can actually get it to apply in a consistent format that you can trust.
And would tooling be an example of one of the subnet types that you guys would have agents do, like search or something like that?
Well, I think the every sub agent for every little problem that we're giving them is just about building tooling to get an LLM to do that task really well.
Okay.
Yeah, I mean
And
cursor, yes, sir.
well, I was just gonna say, you're 21 years old now.
Yeah,
You've been in the
yeah,
game since you were 16.
yeah,
What
yeah.
was
It's been
it
a while.
like starting your software engineering career at 16?
Uh, well, I mean, it wasn't really like a career then. I was like in dental school, I was day trading on the side, and I like very naively assumed it'd be easy to take my trades and make it like programmatic. So I didn't think of it as a career. It just happened to be like that. Um, it was kind of like this thing that I was doing on the side, like a side project that just turned out really, really well. And so I was like, okay, I'll pursue this for a little bit.
Most traders, when they do really well, that's just what they do for the rest of their life. Why'd you decide to move off of trading back into software engineering and building something?
I mean, so I think two things are true. One is that I can always go back to trading if it doesn't work out. Um, and like even now, it's like a risk in all things. But the frank answer is that there's two big things that stand out to me. The first is that it is still like around money. Like there is the whole part of like wanting to build something interesting. But I think the best way to get like really rich is to build like the next generation of just like tooling, which I think this is basically what it is. And the second is that like I'm basically like a software engineer trader. I don't trade by hand. I write code to trade. It's like a very small time quant. And the writing is very much on the wall for my career, um, especially for what I do, which is like smaller niche strategies. And so it's like, okay, either I can try to milk this for a couple years and get replaced, or I can be the one that tries to do the replacing. And I would rather take a swing at doing the replacing than just be like kind of trying to eke out as much money as I can before I get replaced.
And you also had experience with other open source projects, specifically Superbase.
Yeah.
What has your time there been like, and how does that influence your approach now?
I mean, I wasn't there for terribly long. I was there for like a couple months as an intern when they first started. I think it was like number 9 or 12 over there. I learned a lot from them. Like, I mean, they operate very, very well. I think they're like $1 billion company now. Internally, they did this thing like YC, where like they had like little sprints for a couple of months, and then like for a couple of months, the whole company would be sprinting towards something. Maybe they don't do it now for like a much bigger company, but yeah, I just learned a lot about like how like speed is very, very important, and in a very saturated market for them, for example, like that was the competitive advantage that set them apart. Like, they basically came into a market where Firebase, owned by Google, dominated it. And the only reason they won is because they just did it better, faster. They built like a better developer experience, much quicker. They responded to feedback quicker. They made mistakes, but they improved them quicker, and they kind of like just iterated faster in like in a saturated market. Similar, I guess, to like what's going on now, where it's like everyone's trying to build agents, and the tooling available to everyone, unless you're like a big company like OpenAI, is the same. So it's just like who executes the best.
And you're saying the only competitive advantage is who can execute the best. Why do you think you can execute the best? Why are you best suited? Why is your team best suited for this task?
Yeah, I mean, there are competitive advantages aside of that. If you're like a OpenAI, you obviously have an advantage aside just like who's the best execution. I think that like it's not necessarily the case that I'm the best at executing this, anything inherent to me. But I think that like in my career so far, of the things that I've done, my experience has shown that if I try like hell to do something, probably I can get it done. And I think this is a big enough payoff that it's worth kind of like risking some savings to basically give it a shot and see how far I can go.
And out of all of your experience in the past, what is this, 5 years
Yeah,
that
probably
that
less.
you've been a professional because you graduated high school at 15?
Yeah.
Why did that happen, first of all?
Uh,
Before we even get into the career here.
I don't know. It wasn't like a intentional thing. I skipped one grade and then um I don't know. Like in high school, like so I went to school in Ontario. They have like a credit system where you need 30 credits to graduate. And so like the way they do it is like 8 credits for the first 3 years, 9, 10, 11, and then 6 credits for grade 12. And my parents were like, well, obviously like you're not spending that much time on class. Why don't you just do more credits at the same time? And that's basically what happened. Like I just front loaded my classes. It wasn't like a like some big master plan. It was just like I can do it faster, so I may as well kind of thing.
Okay, there you go. So speed has been key for a while for
Yeah,
you.
speed is the only thing that I think about.
Okay. And then out of your extensive career history, what are some
That's
points that stuck out to you and really shaped your worldview and your approach to being a professional and how you approach business and your mindset?
I mean, I'm super early, so I don't know if I'm in a good position to have good answers here. But um, I mean, a few of them are just like helping people where you can. Like for example, like early on in my career, I helped a friend raise a bunch of money because I was using like his company like for some trading thing. And I was like his biggest user. And so he asked me to talk to VCs, and try to like tell them to invest in the company. And I did. Like I explained, like this is a really good company. The stuff that they're building is very hard to compete with. And he raised like I think over 100 million off of my referrals, like just off the emails they forwarded me from VCs saying that because of this referral we're investing. The company ended up getting acquired. But I wasn't expecting anything from it. Like it was just like, he's my friend. I love the product. Let me try to help him. And then kind of gave me a lot of referrals, like introductions to other people that kind of taught me how to trade professionally, to go from like this small shop where I was just kind of like hacking around with Python scripts to like actually doing it as a career and making a good amount. Um, so that's one. And like honestly, like I think like the other one, like it's like a really small world. My paths have crossed with kind of people like a lot over time in like very unexpected ways. Aside from that, yeah, it's just speed is key. It seems like as long as you're diligent and trying to move as fast as possible, usually you can win. It's just about like who can go the fastest and obviously not in like the messiest way, but it's like who can be diligent and go the fastest at the same time. Um, and I guess one more is that like you can probably push yourself a lot farther than you think. Like I worked at Twitter for a bit and it was just crazy how much more like the engineers that I worked with got done in that time frame. It was like absurd. And it's like, wow. Like even now, like so when I talk to some of these guys and I hear what they're doing, it's just like you almost feel like I'm not doing enough because this is how much I could be doing, kind of thing. But yeah, besides that, I don't have much.
What attracted you to Bittensor? When did you find it? What was your introduction to Bittensor?
So I started Agent Hub with two guys. One of the guys was actually on the Twitter transition team with me. And he met a guy in university. And so we were all kind of staying in Toronto, and we were like, let's go out for lunch. And he was like, like I heard this BitTensor thing. It's like super interesting. And he kind of explained it, and I was like, this is kind of weird because like it's about incentive mechanisms, and my whole career up to that point had been incentive mechanisms. How do you incentivize people to behave properly on like a platform? How do you like trade? That's like it's basically just incentives all the way down. And so it just kind of seemed interesting from there.
And then how would you describe Bittensor? Just an incentive layer? What would you say it is? What is Bittensor in your mind?
Mm, I think it's basically like leveraging human nature to the max, just using incentives to try to get like crazy outputs. Um, yeah, I'd say that's how I describe it. Where it's like you can see this used at small scales by companies everywhere. Where like if you want someone to do well, for example, you structure their comp based on their output and performance, and they'll often work a lot harder. Similarly, like if you want an AI model to do well, you do RL to kind of incentivize it to kind of like tune it one way. The tensor is taking that and almost making it like formal theory.
And you had a essay, I believe, on your website that
Oh no.
was, yeah, it was about um, a different way to govern
Yeah.
societies, if I believe correctly.
Yeah.
What do you still stand by your ideas in that essay? I don't know if you even remember the essay because you
I do.
probably did so much in between.
No, no, I remember it. I got funny story. Like when I got hired at Twitter, they actually apparently looked at my website and they were like, "This guy's crazy" off that essay. Um, I think it's interesting. I think it makes sense. It's kind of like the idea of incentives, where like you kind of want people to vote, if they're incentivized to make the right decision and if they're kind of shown that they're good at doing it. Yeah, I think I still stand by that. I don't think that like that necessarily voting should be all equal. I think it should be based on like um, how likely you are to have a good vote on an issue, um, and how likely you are to be incentivized to make like a good vote for everyone. Now, obviously, like an implementation, that's really hard to determine, but like for example, if you have an issue as to like whether like a certain level of drugs should be allowed over the counter, I don't have an opinion on that. I shouldn't have an opinion on that. I'm not a doctor. I don't know what effect it's going to have. I don't know any stats. I've never read a paper on like how this affects populations. There are people that have, and so if we're both voting on it, my vote should not be considered the same as theirs. Um, in practice, it's really hard to implement, especially because nobody votes on smaller issues. But I think that's a whole other thing. Like I'm probably close to the libertarian, where I think that the government should be much smaller, make much fewer decisions, and those decisions should be actually like at a per decision basis, instead of just having one catch-all candidate that's usually just spent his whole life in politics, deciding what should happen.
And judging the who should have the vote here, who has
That's the
the
impossible part.
education,
Yeah.
how do you determine that? How do you
I don't
determine that?
know.
What's the incentive mechanism there?
That's the tricky part. I mean, Bittensor hasn't figured it out either, right? It's like, okay, well, you can get a validator that has a lot of stake, has a lot of tau stake, but it's still like to their incentive, let's say, to like set their miner weights really high. So we have Yuma consensus. Um, that's really that's the difficult part, and especially because someone is deciding that, and that person obviously also has interests. I think that's the part where I didn't finish the essay. I was just like, I didn't know what to say at that point.
And you bring up the Yuma consensus, and there might be perverse incentives for weighting your own miners if you're a large validator.
Mhm.
Are there any issues or things you think will change in BitTensor moving forward at like a higher level of the design of it?
Um, I don't think I've spent enough time here to comment on that properly. I think that like for sure things are going to change, and I think detail is really going to change the landscape of what kind of subnets do well. Um, Beyond that, I don't know. It's not an honest
And
answer.
for detail, you have a interesting idea for rewarding miners extra incentive
Yeah.
for outside revenue you guys bring in. Can you
Yes.
explain that idea?
Yeah. I mean, like, so fundamentally, when we build this platform, right, we'll have like a bunch of miners that are at the end of the day the ones contributing the agents, the ones improving the agents. Um, and there's no real vendor lock-in. I mean, you kind of have like some moat in the sense that like when someone used their product, they don't want to switch. When something's embedded in someone's workflow, they don't want to switch. And that it's like a lot of like tooling to go from taking that agent, deploying it, using it in the right context. But beyond that, like there's no reason why a competitor couldn't form. And so it's like I think one of the better ways to kind of keep that distribution strong is to and also like to be honest, like the fair thing to do is to also give miners like a cut of the revenue that they're making. Um, Unlike, for example, like Devin or Cursor or whatever, like we don't have a high overhead of building our own models. We don't have a high overhead of like R&D because we have like a ton of engineers doing research because that's what the miners are doing. Um, and so it's only fair that those guys also get a cut of the money that they're making as a result. So it's like our overhead would be very low. It would basically be payroll of the underlying company, whatever little R&D we do internally, but that's most like incentive mechanism related R&D of like running benchmarks on miner output, stuff like that. And so the margin like that we would make, like Cursor is at what, 500 million ARR as of today, they announced. Our margin would probably be like way higher than them, like 80, 90% easily, maybe probably more. Like I can't imagine our costs would get that high. And so that margin can and should be allocated towards keeping that network strong, keeping like the foundation that allows that margin to come in the first place. Almost incentivized to stay there and want to kind of continue to be part of it, build it, even like catch exploits and like make sure the quality of agents overall is going up outside of their own agents because it means more users for them, more revenue for them.
And going forward, what are your boldest ideas for where Subnet 62 can go? Where do you want to go? What's your we've achieved success when we hit XYZ?
Software engineers are gone and entirely replaced by agents on our platform.
All of them, 100%.
Everyone gone. You don't need anyone.
How far off do you think we are from that actually being a reality?
I can't say. I think the space is moving very fast. Possibly it plateaus, possibly it doesn't. I think that the models are good enough to do it. I think it's probably like a year and a half of just like incentive fighting. Maybe I'm very off, but yeah, I don't think we're. I think it's at most a couple years away from being able to take it because the models are good enough, and so it's just a matter of like building the tooling around the models to allow them to do this. I think.
So you believe the current models are already good enough to do this. What is stopping all software engineers from being replaced?
The tooling, like even if you know the models are good enough for this, let's say you're like a product manager or someone that wants to build a company. How do you actually start and go there and like actually build a product end to end by just talking to a model? You don't. There's so many things you have to consider. There's like deployment of your code. There's like what kind of code do you even write? There's like fixing bugs in the code written by other LLMs. Right now you need to be like a software engineer yourself and have like a lot of context on how agents view these things to be able to reliably do that. And I mean, there's very clearly appetite for people building this kind of tooling around it to at least abstract some of it away. Like you look at like Bolt and Lovable, they're small companies. They're at I think like what 10, 20, 30 million ARR within a few months of starting. And all they do is kind of like pick a niche of this, which is like a front end website. You ask it a problem, you ask it something that you want, like I want a website that looks like this, and it does the steps. It figures it out. It tries to plan it. It starts up a Next.js project, like a basically a website project. It installs the things that it needs to. It tries to come up with code for the different designs, and it tries to integrate it and show you. And even that, which is like not fully ready to go and like harder to iterate on, already has massive ARR. Um, but I think that that's what's needed. Like, how do you actually go from this instruction, I want to build this, to actually building it out? Um, like, I mean, their agents are already pretty good. I mean, that they're doing it, and they have like people full time working on the tooling around these agents to get them to be able to do that. But I think the whole power of this thing is that you don't need to hire engineers to do that. You can just get the Bittensor miners to do it, and because they're constantly competing, they will constantly be getting better at every angle of this. Where a company like that has to constantly basically allocate engineers, who, by the way, are not incentivized to do better on an individual basis, to compete with miners relentlessly focusing on each part of these toolings, to basically produce this product.
And Bolt.new is a good example of something that you would consider a soft task that miners do, in the
Yes.
sense that it's subjective. And how do you evaluate which front end looks better?
Yeah,
You
exactly.
guys implemented I believe you refer to it as a ELO system for that.
Hmm. Yeah,
Can you explain how that works?
sure. I'll be honest, it's very brittle, and we're moving away from it pretty soon. But the short and long is that like you basically get the LLM to compare two patches, and you get it to explain why one is better than the other. And so it's like chess, where like let's say you have 25 responses to a problem. First of all, it's very expensive to do this because of this, but let's say you have 25 responses to a problem. You start making them compete, and there's always a winner and a loser, just like chess. If you're like a very good patch and you lose to another patch that's like not as good, it probably means that you're not that good. In the same way that if you're a very good chess player and you start losing to very shitty chess players, it means that you're probably not as good. And so, similar to chess, we implement like an elo system for the patches, where as we're comparing them with the LLMs, we create as many matchings as possible, and then we keep track of a given solution's elo score, so to speak. And then as we compare it, it'll win or lose versus another solution. And based on the other solution's elo and its elo, you can basically compute the new elos and keep going. And in internal benchmarks, it's like pretty consistent as to like how the grading is done. Like the LLMs tend to like pick the same patches and the same ranking structures, but it's very arbitrary and still a bad solution. I think a free market for this is a better solution.
Okay, a free market for this. What are you guys transitioning to? You said you're transitioning away from
Yeah.
ELO. What's the new thing that's going to be in
So
like a week or whatever
yeah,
timeline
it's
you're
a
on?
couple of weeks, maybe like a week and a half. Um, it's basically like this system of people publishing their code and being evaluated on small hard tasks. So context selection is one kind of task that we're gonna have, instead of just code generation. Like we're kind of moving away from code generation and moving to like context selection, regression, unit test stuff, that kind of stuff. That's like easier to kind of check. And we'll have like a lot of small tasks for that. And then we'll reintroduce the soft tasks when it comes time to actually like integrate larger problems and allow the miner to basically receive a contract, and it has to find the soft task agent it wants to use and pay.
So you want to encourage miners essentially to outsource the work to other agents that already exist and not
Yes.
necessarily develop their own solution.
Yes. I want there to be orchestrator agents. I want the miners to also figure out this problem of how do you string them together. And we will build a lot of tooling and like standardized tooling for them to like kind of interface with each other. But the order in which you pass problems off to different miners, the miners that you choose to do so, we want them to kind of figure it out. We want to basically like focus on eventually building an incentive that makes it like so that we can look at the final response and judge that and kind of evaluate the orchestrator models on that.
And in the past 3 weeks of redesigning everything, what have been
Yeah.
the hardest problems that you guys have encountered?
Um, there were two problems. One of them was just in terms of everyone onboarding and getting to learn like how minor weights work, looking at distributions, but that's pretty solvable. The other problem is kind of like it's a whole new system. I don't think there's many systems like this. And so you kind of have to like design a lot of new things from scratch and spend a lot of time thinking about how people could adversarially break it. So, for example, when people publish their agent code, what does that mean? Are we just publishing random code that can be run in random ways? No, there needs to be like a standardized way to do it. So how do you design a standardized way that is open enough that allows miners to innovate in as many ways as possible? Like we don't want to tie their hands in terms of what their agents can do in like this little sandbox environment. But at the same time, We don't want them to be able to break out of that environment. Imagine like a validator is running some minor agent code, and the agent code breaks out of the sandbox and takes their cold keys from their computer. That's not good. Um, so it's like a lot of design considerations like that, and it's like we not almost we do run like internal incentive mechanism games on this new incentive mechanism that we're trying, where like one guy is basically building it and the other guy's job is to try to break it. And that's a really hard thing to do because especially like for stuff like a sandbox where you're running arbitrary code, you need to get that right.
And running it in a sandbox, do you guys just use Docker for that?
No, we built our own custom sandbox software. The way it works is that there's like a spec the agents have to follow, and then we give them access to like a couple ports. Basically, like the only internet access they have is asking our platform to do inference or embeddings for them, and nothing else. Um, And then like we basically built a way that that interfaces with the validator. The validator can run up to 256 of these sandboxes concurrently without taking up too much space on their computer. We allow them to specify we don't allow them to specify packages, arbitrary packages to install, but we let them run in like a very limited kind of shell environment, like if they want to run computer commands within their little Docker instance, stuff like that.
Do you anticipate any scaling problems with this if you have to run all these different sandboxes?
Well, the validator runs it. We do definitely anticipate scaling problems, and that's like also like one of the hardest problems we're thinking about right now. How do you kind of like solve this? Who bears the cost of inference? Um, kind of like what are different ways that different people could do to try to like, for example, if they wanted to attack this, let's say some like a competitor company, and they wanted to basically slow us down. Well, one way you could do it is just by making like infinite loops, stuff like that. There's a lot of stuff that we're considering here as to like kind of like how do you build this out properly?
And who do you view as your competitors in this space? Would you say there's anyone in the traditional world that you see as a competitor here?
For sure. There's definitely a lot of smaller companies that are quiet and not talking about it. They're trying to build like an end-to-end solution internally before going public. Devin is a good example. And I won't say that they faked their demo, but there was rumors that they faked their demo or like YouTube videos about it. And I think that's like it's kind of really hard to build that end-to-end thing. There are parts the agent will get wrong in between. But certainly there's tons. I can't imagine that Cursor Windsurf wouldn't eventually also try to expand and build like an async agent.
Okay, we've covered a lot of ground here.
Thanks.
Um, yeah. What are your thoughts on detail in general? Or are you just so locked in on the subnet game that you don't even look?
Um, I mean, it's tricky. So my main thought on it is that like I think, and maybe I'm wrong about this, I feel like you need to generate revenue sooner than later. You cannot live off emissions because now everyone's incentives are flipped against it. If I, as a subnet owner, want to be dumping my emissions to fund my team, that pushes my price down, which pushes my emissions down, which pushes the minor quality down. Um, and before that was kind of true, where like everyone sold Tau, and so the Tau like value kind of went down, which kind of attracted maybe less miners in theory. But but now it's like directly like your project gets screwed if you're kind of like pushing it down. Beyond that, I don't have any thoughts about it. I think the core of like kind of setting up the incentive mechanisms is still intact.
Do you have any, I I hate to use the word flywheels, but tokenomics ideas besides just buybacks for the alpha token?
I did. And I got feedback from someone that's actually quite experienced with this that it eventually creates like a Ponzi situation, so I killed that. Um, so yeah, other than that, not really. I mean, I think the biggest one is to just drive revenue. Build a really good product and have miners get paid for actually for you for doing their product. Like do like a revenue share, and that problem kind of solves itself. Especially because then their costs are abated and they want to hold it because like the alpha token is almost like a stock. It's not a stock, but it's almost like something that represents your company. And so like they want a piece of that if the product is just getting better.
Yeah.
Yeah.
Well,
I do.
Shaquille.
Yeah. Sorry,
No,
I do think
no.
that there is actually one very cool flywheel in the new incentive mechanism though. Um, in that like in the previous model, like if someone had like a dominant agent for a specific type of coding task, it's hard to compete as a new miner and get incentives because you can't see what they're doing to kind of get their agent to that point. And it's expensive to kind of do testing with agents. You're making like a lot of AI LLM calls basically. It gets pricey. I think that like this new model where like everyone can see everyone else's code allows the competition itself to become like a flywheel, where like if I can see another miner's code, as soon as I as a miner publish the dominant code that everyone can see is scoring the best, the clock is ticking, because someone else can take that code, and run it themselves. The way we're setting it up right now is not that. Like if you take someone else's code and run it yourself, you don't get rewards. But if you do take someone else's code and you improve it further, you do get rewards. And now, like, so basically, if I'm a miner and I publish the best agent code, and someone else basically sees that and improves it, and now I'm no longer the best miner. I basically have to constantly be on my toes and improving. And it creates like the situation where like it gets more and more intense competition. Where like I think what's going to end up happening is that people are going to write agents to write agents instead of writing the agents themselves, because it eventually becomes too much competition too fast. Where like almost a better thing to do is to build an agent that can look at all the innovations that people are doing currently on the platform and also write further innovations on them. And it creates like a feedback loop where like now agents are competing with each other to write better agents, if that makes sense.
Okay. Where they publish their agent code,
Hmm.
is it winner take all in each niche or subsector? So like say you have context selection and unit
Yeah.
tests.
Yeah.
Would it just be one winner in each?
Much
Or
closer to
how
that.
does
Yeah.
the distribution work?
Well, right now the distribution is kind of like fairly even, with like the top miner is getting a bit more, but not like 10 times more than the next best miner. I think you basically have an exponential model now, where like you kind of want the very top cluster of models to be always be getting the bulk of the reward, because everyone can see their code, and so they can just take it and improve on that. And if they improve on it, that guy should get most of the reward, which then forces the previous miner to continually improve.
Is there some sort of decay function to where you're not just going to have one model that sits there for 3 months as the best model? Or,
No, no. The decay function is that anyone can see the code, and if they can figure out a better way to implement it in that model or improve on that model, then they can do so and take your share.
okay. Well,
Yeah.
Shaquille, I'll ask you one last question here today,
Sure. Sounds
and
good.
that is, what advice would you have for your younger self
For my younger self. Um,
now that you're old and wise, you know?
oh yeah, now that I'm old and wise. And to be honest, it's probably just move faster. Like there were a lot of times where like I spent a couple months kind of like mulling over decision whether I should do something. And in those couple months I could have just taken the risk, maybe gotten burnt, but I think I would have been further ahead right now if I just like solely kept my focus on just kind of like um just going all in all the time.
All right. Well,
Yeah.
Shaquille, it was fun having you on, man.
Cool.
And
Thank you. I appreciate it.
excited for your future, man. Thank you.
Appreciate it. Thanks so much, man. Take care.
Absolutely.